Hey there, science fans! Welcome to another exciting journey through the wonders of our universe. Ever wonder why we have seasons, why the weather changes so dramatically from winter to summer? And why some days are longer than others? Why the sun seems to hang in the sky forever during summer, but barely makes an appearance in winter? The answer lies in a fascinating cosmic quirk: Earth's tilt. This tilt is the reason behind the rhythmic dance of our seasons. Picture this: Earth isn't perfectly upright like a spinning top. Instead, it's tilted on its axis at about 23.5 degrees. This tilt might seem like a small detail, but it's crucial. Imagine a giant invisible rod running through the Earth from the North Pole to the South Pole. That's our axis, and it's what our planet spins around. This tilt causes different parts of Earth to receive varying amounts of sunlight throughout the year. As Earth orbits the Sun, this tilt means that sometimes the Northern Hemisphere is tilted towards the Sun, and at other times it's the Southern Hemisphere's turn. Now, this tilt might seem small, but it plays a huge role in how much sunlight different parts of Earth receive throughout the year. When the Northern Hemisphere is tilted towards the Sun, it experiences summer while the Southern Hemisphere enjoys winter, and vice versa. This uneven distribution of sunlight is what gives us our seasons and influences the length of our days. During summer, days are longer because the sun takes a longer path across the sky. In winter, the days are shorter because the sun's path is much shorter. So, buckle up as we explore how this tilt affects the length of our days. We'll dive deeper into the mechanics of Earth's tilt and how it shapes the world we live in. From the longest day of the year, the summer solstice, to the shortest day, the winter solstice, and everything in between, we'll uncover the secrets of our planet's cosmic balancing act. Twice a year, something special happens. Around March 20th and September 22nd, we experience the equinoxes. During an equinox, the Earth's tilt is sideways relative to the Sun. This means that the Sun's rays hit the equator directly, dividing the Earth into almost equal halves of light and darkness. Because of this, day and night are roughly the same length all over the planet, about 12 hours each. That's why it's called an equinox, which comes from the Latin words for equal and night. However, even during the equinoxes, day and night aren't perfectly equal. This is due to factors like Earth's atmosphere bending sunlight and the way we define sunrise and sunset. As Earth continues its journey around the Sun, we reach a point where the tilt of our planet's axis is pointed most directly towards the Sun. This happens around June 21st and marks the summer solstice in the Northern Hemisphere. On this day, the Northern Hemisphere enjoys its longest day and shortest night of the year. The further north you go, the longer the day gets. It's like the sun doesn't want to set. Why is that? Well, the tilt makes the Northern Hemisphere lean towards the Sun, meaning it receives more direct sunlight for a longer period. 6 months later, around December 21st, the tables turn. The Earth's tilt points away from the Sun, marking the winter solstice in the Northern Hemisphere. Now, the Northern Hemisphere experiences its shortest day and longest night. Remember those long summer days? They're replaced with shorter periods of daylight and a longer stretch of darkness. But don't worry, the Southern Hemisphere is having its turn to soak up the sun. Down south, they're celebrating their summer solstice with their longest day of the year. Section 5. Latitude's role. Tilted further, longer days. Remember how we talked about the Earth's tilt? Here's where it gets even cooler. The angle of sunlight changes depending on your latitude, which is your distance from the equator. During the summer solstice in either hemisphere, the pole tilted towards the Sun experiences 24 hours of daylight. That's right, the Sun never sets. As you move closer to the equator, the difference in day length between summer and winter becomes less extreme. At the equator itself, day and night are always about 12 hours long, regardless of the season. Section 6. The tropics, where the sun always shines bright. Let's talk about the tropics, the region near the equator. Because the equator receives the most direct sunlight year-round, the tropics experience relatively minor variations in day length throughout the year. Imagine living in a place where the days and nights are always about the same length. That's life in the tropics. This consistent amount of sunlight is why tropical regions are known for their warm temperatures and lush vegetation. Section 7. The poles land of the midnight sun. Now let's travel to the poles, the extreme north and south points of our planet. Here the effects of Earth's tilt are most dramatic. During their respective summer solstices, the poles experience a phenomenon called the midnight sun. The sun never sets, and the sky is bathed in sunlight for weeks or even months. Conversely, during their winter solstices, the poles plunge into perpetual darkness. The sun doesn't rise, and the night seems to last forever. Section 8 Seasons, a dance of tilt and sunlight. So, how does all of this tie back to our seasons? The answer lies in the intricate dance between the Earth's tilt and its orbit around the sun. Well, it all comes down to the angle of sunlight and the amount of heat that different parts of the Earth receive throughout the year. This angle is constantly changing as the Earth orbits the sun, leading to the cyclical nature of our seasons. When a hemisphere is tilted towards the sun, it receives more direct sunlight and experiences summer. This tilt means that the sun's rays are more concentrated and intense, warming the surface more effectively. The days are longer, and the sun's rays hit the ground at a steeper angle, leading to warmer temperatures. This is why summer days feel so much longer and hotter compared to other times of the year. Conversely, when a hemisphere is tilted away from the sun, it receives less direct sunlight and experiences winter. The tilt causes the sun's rays to spread out over a larger area, reducing their warming effect. The days are shorter. The sun's rays hit the ground at a shallower angle, and temperatures drop. This is why winter days are shorter and colder, with the sun appearing lower in the sky. The transition between these seasons is gradual, marked by the equinoxes and solstices. During the equinoxes, day and night are nearly equal in length, signaling the start of spring and autumn. The solstices, on the other hand, mark the longest and shortest days of the year, heralding the peak of summer and the depth of winter. These celestial events are a direct result of Earth's axial tilt and its orbit around the sun. This dance of tilt and sunlight not only affects temperatures, but also drives the rhythms of life on Earth. Plants bloom, animals migrate, and ecosystems transform in response to the changing seasons. Even human activities are deeply influenced by this cycle. Agriculture, festivals, and daily routines are all aligned with the ebb and flow of the seasons, showcasing the profound impact of this celestial dance on our lives. Section 9. Life's Rhythms, Tuning into Earth's Tilt. The tilt of our planet is more than just a cosmic quirk. It's a fundamental force that shapes the very fabric of life on Earth. Earth's tilt doesn't just affect the length of our days and the seasons, it orchestrates a symphony of natural rhythms that govern the lives of countless organisms. This tilt influences countless life forms on our planet, from the tiniest microorganisms to the largest mammals. Many plants and animals have adapted to the changing seasons and day lengths. For example, some trees shed their leaves in the fall as the days grow shorter and colder. This process, known as abscission, helps trees conserve water and energy during the harsh winter months. The vibrant colors we see in autumn are a result of this adaptation, as trees prepare for the winter by breaking down chlorophyll and revealing other pigments. Animals like bears hibernate during the winter months when food is scarce. Hibernation is a survival strategy that allows them to conserve energy by significantly lowering their metabolic rate. Our own sleep-wake cycles are also influenced by the amount of daylight we receive. The circadian rhythm, our internal body clock, is synchronized with the natural light-dark cycle of our environment. Our bodies produce melatonin, a hormone that regulates sleep in response to darkness. This hormone signals to our body that it's time to rest, helping us maintain a healthy sleep pattern. That's why we tend to feel more tired in the winter when the nights are longer. The extended darkness leads to increased melatonin production, making us feel sleepier and more lethargic. Understanding these natural rhythms can help us better align our lives with the Earth's cycles, promoting overall well-being and harmony with the world around us. Section 10, Tilted Earth, Tilted Perspective. Earth's tilt is a reminder that we live on a dynamic and ever-changing planet. This seemingly small tilt has a profound impact on our lives, from the length of our days to the seasons we experience. So the next time you step outside and feel the warmth of the sun on your skin or shiver in the chill of winter, remember the cosmic dance between Earth and the sun. It's a dance that's been going on for billions of years and continues to shape our world in countless ways. Keep asking questions, keep exploring, and stay curious.